The Papillon system employs a modular DSPy architecture to balance response quality and privacy preservation, leveraging an external LLM for enhanced capabilities while mitigating PII leakage through a two-stage pipeline. We will examine how the system initializes its components, processes user queries through privacy-preserving transformations, and evaluates performance using specialized metrics that quantify both response quality and information leakage. Def compute metrics gold, pred, trace equals none. Return LLM JUD. User query equals gold, user query. New resp equals pred, response. Og resp equals gold, target response. Updated query equals pred, LLM request. Pay SDR equals gold, pay SDR. Def compute quality gold, pred, trace equals none. Return compute metrics gold, pred, trace quality. Def compute leakage gold, pred, trace equals none. Return compute metrics gold, pred, trace leakage. Def compute overall score gold, pred, trace equals none. Metrics equals compute metrics gold, pred, trace. Overall score equals metrics quality plus 1 metrics leakage /2. Return overall score equals 1. If trace is not none else overall score. This code implements a metric computation system for evaluating the Papillon privacy-preserving delegation framework. The core pattern is a modular metric calculation architecture that separates concerns while maintaining consistency through a shared foundation. The compute metrics function serves as the central hub, delegating to an LLM judge module that evaluates both response quality and privacy leakage. This follows a facade pattern, providing a unified interface to the complex judgment logic while hiding the implementation details of the LLM-based evaluation. The quality assessment uses a bidirectional comparison approach, checking if the new response is at least as good as the target response in both directions to handle potential judge inconsistencies. Privacy leakage is calculated by normalizing the count of leaked PII elements against the total PII elements present. The architecture demonstrates a clear separation of concerns through specialized functions. Compute quality and compute leakage extract specific metrics from the comprehensive evaluation, while compute overall score combines these into a balanced metric. The overall score calculation uses a simple average that weights quality and privacy equally, with a special case for trace scenarios where it returns a Boolean success indicator. This design allows for flexible metric composition while maintaining consistency in the underlying evaluation logic. The approach balances simplicity with sophistication, using LLM-based judgment for nuanced evaluation while maintaining straightforward arithmetic for final scoring. The trace parameter handling suggests this system supports both training and evaluation modes, adapting its output format accordingly. This modular design enables easy extension or modification of individual metrics without disrupting the overall evaluation pipeline. Let's break it down. Def compute metrics gold, pred, trace equals none. Defines a function named compute metrics that accepts 3 parameters: gold, pred, and an optional trace parameter defaulting to none. The function is designed to calculate and return evaluation metrics by comparing ground truth values, gold, against predicted values, pred, with the optional trace parameter likely used for debugging or logging purposes during metric computation. Return LLM JUD. Returns the result of calling the LLM judge function with unspecified arguments. The function appears to be a language model-based evaluator that processes inputs and generates a judgment or assessment, though the specific parameters and their values aren't visible in this segment. The return statement indicates this evaluation result will be passed back to the caller. User query equals gold, User query. Assigns the value of gold user query to a variable named user query. This copies the user query from the gold object, likely a reference or ground truth object, into the local variable for use in the current scope. New resp equals pred response. Assigns the value of pred response to a new variable new resp. This captures the response from a prediction object, likely storing it for further processing or output. Og resp equals gold target response. Assigns the value of gold target response to a variable named og resp. This captures the expected or correct response from a reference object gold for later comparison or validation. Updated query equals pred LLM request. Assigns the value of pred LLM request to the variable updated query. This captures the LLM request generated by the predictor object into a new variable for potential further processing or inspection. Pay SDR equals gold. Pay SDR. Assigns the value of gold, pay SDR, to a variable named pay SDR. This passes the PII personally identifiable information string from the gold object to be used elsewhere in the code. Def compute quality gold, pred trace equals none. Defines a function named compute quality that takes 3 parameters: gold reference value, pred predicted value, and an optional trace parameter defaulting to none. The function is designed to evaluate quality by comparing the predicted output against the ground truth, with the optional ability to include debugging or tracing information through the trace parameter. Return compute metrics gold, pred trace quality. Calls compute metrics with gold, pred, and trace as arguments, then returns the quality attribute of the resulting object. Def compute leakage gold, pred trace equals none. Defines a function named compute leakage that takes 3 parameters: gold, pred, and an optional trace parameter defaulting to none. The function is designed to calculate some form of leakage metric, likely comparing ground truth, gold against predictions, pred, with trace potentially used for debugging or logging purposes. The actual implementation details of the leakage computation are not visible in this segment. Return compute metrics gold, pred trace leakage. Calls compute metrics with gold, pred, and trace as arguments, then returns the leakage attribute from the resulting object. Def compute overall score gold, pred trace equals none. Defines a function named compute overall score that takes 3 parameters: gold reference ground truth, pred prediction, and an optional trace parameter defaulting to none. The function is designed to calculate an overall score by comparing the gold standard against the prediction, with the optional trace likely used for debugging or logging purposes. Metrics equals compute metrics gold, pred trace. Calls compute metrics with 3 arguments: gold, pred, and trace. The function returns a metrics object, which is then assigned to the variable metrics. Overall score equals metrics quality plus 1 metrics leakage /2. Calculates an overall score by averaging 2 metrics, quality and the inverse of leakage. The quality metric is used directly, while leakage is inverted 1 leakage before being combined. Both metrics are given equal weight in the final score, which is normalized by dividing the sum by 2. Return overall score equals 1 if trace is not none else overall score. Returns a Boolean indicating whether overall score meets or exceeds 1 when trace is not none, otherwise returns the raw overall score value. This conditional logic ensures the return type adapts based on the presence of the trace object. The Papillon system's metric computation architecture demonstrates a clean separation of concerns through a facade pattern, where compute metrics serves as the central hub that delegates to an LLM-based evaluator. This design allows specialized functions like compute quality and compute leakage to extract specific metrics while maintaining consistency in the underlying evaluation logic. The overall score calculation balances quality and privacy equally, using a simple average that weights both metrics identically. The trace parameter handling reveals the system's dual-mode capability, adapting its output format for both training and evaluation scenarios. This modular approach enables flexible metric composition while ensuring the evaluation pipeline remains robust and extensible.
The metric judges quality, hides leakage, then erases itself when compiling its own trace.